going to science the shit out of it. Okay? So you guys have been really inspired in the last few talks. So what I want to do today is give you a bit of a taste, if you want to get involved, if you want to be part of it, a few of the steps that you might take, and a few of the new things that are coming out of Silicon Valley that help solve what we call wicked problems. What Jonathan was talking about, energy and water and food and climate and conflict and women and all of these issues. How can we start to science the shit out of that? And it starts with data. So with all of this new data that we have and our ability to store petabytes of data and process it much faster, we've actually got a new problem. How can we use that data to solve the really difficult problems, poverty, conflict, military, and if I'm a company, how can I use that data to help me make more money and beat my competition? And if I'm a medical provider in sub-Saharan Africa, how can that data help me decide where I should get my medicine and which doctors I should train? How can we make that connection between data and the problems that we really care about? And there's a lot of problems here. And one of the key things is that there's interdependencies. As Jonathan showed, food, water, and energy are all interrelated, but that's not all. There's a lot more. As we make decisions around food, it impacts water. As we make decisions around water, it impacts energy. Energy decisions impact the status of women around the world. They're all interrelated. How can the data help us to understand if we make a decision in one place, how it affects and impacts decisions in other places? What can we do with all of that? So again, I want to give you guys a taste of two things that are happening right now. Has anybody heard of deep learning or machine learning? Ah, great, there's a few hands, so it's not brand new. So for those of you who haven't, I'm going to give you just a little bit of a taste of this. And I've been doing machine learning in various forms for 30 years with all kinds of companies, from the Human Genome Project to marketing companies. I kicked off with a rheumatoid arthritis company today, which was very exciting, and I look forward to working with them. And all of them are taking advantage of all of this new data that's so cheap and so easy to process. And it's pretty simple, actually. If you just look at the outside of the box, what you do is you get humans to show the computer what they want it to do. So in this example, we get a whole bunch of photographs, and we get humans to put little boxes around the faces. Okay, pretty simple. And what we're trying to do is we're going to teach the computer what a face looks like. We feed all that data into the deep learning engine, and don't worry about the inside of it. Although what's pretty cool about the inside of the deep learning engine is it uses something called a neural network, which works kind of like the human brain does. It's not perfect, but sort of. And then the deep learner, after it's churned away on great big servers, produces something called a learned model. And now the computer, without having to program it, just giving it some examples, can do that task. And that's pretty cool, right? So we didn't have to write the program. Instead, we gave it examples. Now we show it a picture of Ellen and all her buddies there, and it can automatically put a square around each face. Okay? So this is what Jan LeCun at Facebook does. He built systems that do face recognition for Facebook. And how many of you have seen that within Facebook, where it puts a little square around your face? Yeah, that's pretty common. This is kind of what Amazon does. So all the people and all the books that they all bought, feed that into the deep learning system, and then it says, okay, you're like this other guy who liked this other book that you haven't bought yet, so let me recommend this other book to you because I feel like you like that book or books like that book. And that really helps Amazon. There's a ton of examples like this. So this is how Netflix decides which movies to recommend, how Pandora picks your song list, and how Google decides which ad to show you. So machine learning and deep learning, most recently, are very, very powerful technologies. They're better in some ways than traditional statistics because they can look at a giant amount of amorphous data, and they can find what are called very weak signals. They can relate all the different pieces together and figure out what's going on and how to solve that problem. The real key is that they've got great performance. So a computer that does deep learning last year exceeded humans' ability to look at pictures and say, oh, that's a picture of a cat, that's a dog, that's a camera, that's a man with a camera standing there with brown shoes. Okay? So for the first time now we have, using deep learning, we have the ability to do this much more sophisticated image recognition, but hundreds of other things. And in fact, I think a VC recently said that pretty much every important company in Silicon Valley for the next 10 years is going to use machine learning. It's that important. We've got that much data that everybody thinks has all this value locked up in it, and deep learning is going to be pretty important for that. Okay. Yeah, it's got great performance. Okay, but deep learning, machine learning isn't enough. Turns out there's another problem, and this decision intelligence is much newer. It's only started to really take off the last 6 months. I've only given a few talks, and a few other people have given a few talks about it. So here you are at the ground floor, and you can start doing this right away just by drawing some decision intelligence pictures. And this is the problem that decision intelligence solves. It says, if I make a decision today to put Omega in Halong Bay, what will the results of that be in terms of the impact on the local jobs, the impact on carbon sequestration, the impact on our ability to make money doing that if we're an entrepreneur, the impact on the local aquaculture industry? How do decisions that we make ripple through time and produce some kind of result? That's a really important question, right? How does the decision that you make to choose to go to a particular college or not to go to college or to choose an alternative college, how will that impact your future? And how can we understand that connection between decisions we make today and the outcomes they produce tomorrow? And the key thing to get, if you get nothing else, is that a decision by its very nature is forecasting through time. The why of a decision, why do we choose to go to this college? Because it'll cause this to happen, and that to happen, and this to happen, and this to happen, which will eventually make you very successful and very happy and cost your parents an arm and a leg in terms of your tuition, right? So there's a number of outcomes that will happen. And what is that mysterious thing on the inside that gets us from the decision to the outcome? So this is the key question. If I make this decision today, what will be the outcome tomorrow? And what's very interesting is with all of Silicon Valley and everything that's going on here, we're not spending a lot of time and effort answering that kind of question. Let me try to go back. Because this is cool, and you need to see it all at the beginning. Okay. So this thing where we label the images, that's like one link, right? It takes us from one thing to the next thing. But when we get from a decision to an outcome, that's a bunch of links. That's maybe we're going to decide to launch a new kind of phone, and it's going to have this kind of product, and that will attract this many users, but it'll cost us this much money, and those users will tell their friends through a social network. So there's a ripple effect, and the traditional way of doing machine learning and data in general doesn't do that multi-linked thing that gets from cause to effect to the outcome. And that's what decision intelligence is all about. So I thought for fun, I would show you a decision model I built for Omega. And this is really what we're talking about when we talk about decisions that we might make and how they might produce outcomes. So what you can see over here is we're moving up and down the number of hectares of the size of the Omega installation. And then we're also making assumptions. We're saying, well, this is a place where we can get some tax benefits by having solar energy. That will or won't be true, so we can make an assumption there. We might choose to have solar in this installation. We might choose to do wastewater management. We might choose to produce biofuels. And what you can see happening visually here is the impact on things. The monthly financials, right now it's not so good. It goes down all the time, right? Oh, there it goes. We make some decisions that actually mean that my investment eventually turns around and goes back and produces a financial return on investment, completely aside from all the environmental benefits, because we have to get these private-public partnerships working so people make money as they do Omega installations. And then in the lower right, it's not so clear there, it's the amount of carbon sequestered, the amount of jobs produced, the other impacts that happen. Okay, so what we're doing now is we're building these very interactive visual models that help us use data, that's part of the equation, but they help us really ask that question, if I make a decision today, how will it impact my outcomes tomorrow? Another thing we do here is much of Silicon Valley involves fully automatic decision making, like the ad from Google that goes to your computer. That's automated. When Amazon recommends a book, that's fully automated. This approach gets humans into the loop because we don't always have all of the data. So we need to work in a collaborative way to add intelligence augmentation, IA, to AI, which is Usually people think of deep learning and machine learning as part of AI, and that's really important. And deep learning is an ingredient here. Deep learning helps us when we have a lot of data about a part of a system. It helps us get those links right and learn those weak signals that take us from one thing to the next. Also, by the way, we're getting much smarter when we do this because we're moving into a visual motor space. And you guys who are artists, you know that when we put our hands on things and when we look at something visual, we're much smarter than when we just stand there at the United Nations or on C-SPAN and talk about it and don't move. So we're activating new parts of the brain when we do these interactive models. And really understanding these complex systems is, in my opinion, the most important literacy for the 21st century. So I encourage you to start thinking of the world in this way and start to engage in your own wicked problems. There's a lot of people in Silicon Valley doing this. This is just a map of a few initiatives that I've had some involvement in. And so I'll encourage you to take a look at the wicked problems and try to understand them in terms of these very complex connections between decisions and outcomes. And thank you very much.